Hi viewers, welcome to my class on mechanics of materials. In today's class, we will work out numerical examples to find the normal and shear stress on a given plane when a body is subjected to plane state of stress. Let us start with the first example. At a point in a strained material, the stresses acting are as shown in figure. Find the magnitude of the normal and shear stress on a plane inclined at 30° counterclockwise from the vertical. So at a point in a strained material, the stresses acting are as shown in figure. So you have normal tensile stress in x direction of magnitude 30 megapascal and tensile stress in the y direction of 20 megapascal, and also we have a shear stress 4 megapascal associated with this. So the question is to find out the normal and shear stress on a plane inclined 30° counterclockwise from the vertical. So this is a vertical, from their counterclockwise direction 30°. So on this plane, what is the normal stress? Normal to this plane, what is the stress acting? And along this plane, shearing stress we need to find out. So normal to this plane, what is the stress acting? And along this plane, what is the stress acting? So we have already learned how to find out the normal stress and shear stress on a given plane. So let us work out. The normal stress in x direction is 30 megapascal. So tensile stress has to be taken as positive. And again, in the y direction, you have tensile stress. And tensile stress on this face, it will be upward. Okay, so it is positive. Tensile stress is positive. So on the right face, rightward is positive. On the top face, upward is positive. And coming to the shear stress, on the right face, if it is upward, it is considered as positive. In the derivation also, we have taken the shear stress in the upward direction, so that is considered as positive. If it's downward on the right face, all other directions will change. If on the right face, if it's downward, all these shear stress direction will change. You have to see only on the right face. If it's downward, you have to take negative. So shear stress sign is on the right face. If it's upward positive, downward negative. Now the angle you have to measure in the counterclockwise direction. If the counterclockwise direction is considered as positive. If the plane is like this, if it's in the clockwise direction from the vertical, if it's inclined 30°, then you have to take minus 30. Now this plane is plus 30 counterclockwise from the vertical, so plus 30. You can measure the same plane in the clockwise direction. So if you measure in the clockwise direction, the angle will be minus 150. Total is 180. You can subtract 30, so it is minus 150. So you can use either plus 30 or minus 150 for the angle. Now let us find out the normal stress. Normal stress on a given plane is given by sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Sigma x is 30 plus 30, sigma y is plus 20. So 30 plus 20 by 2 plus 30 minus 20 by 2 into cos theta is 30°, cos 2 theta, so cos 2 into 30 plus shear stress tau xy is 4 megapascal plus 4 into sin 2 into angle is 30. So you get 50 by 2 25, 30 minus 20 10 by 2 5, cos 60 plus 4 sin 60, or it will work out to 30.964 megapascal. Since you are getting positive, that means the normal stress is tensile. On this plane, you are getting a normal tensile stress of magnitude 30.964 megapascal. Now shear stress on that plane is the equation is tau is equal to sigma x minus sigma y by 2 sine 2 theta minus tau xy cos 2 theta. So sigma x is 30, sigma y is 20. So 30 minus 20 by 2 sine 2 into theta is 30 minus tau xy is 4 cos 2 into theta. So 30 minus 20 by 2, that is 10 by 2, 5 sine 60 minus 4 cos 60. So it will work out to 2.33 megapascal. So shearing stress on this plane is 2.33 megapascal. So forces will act like this, which is shearing along the plane. The stress is 2.33 megapascal. I'll show you the normal and shear stress on that plane. So normal stress is acting like this. Normal to the plane, so much is the magnitude 30.964. So as a result of this stresses on this plane, which is inclined 30 degree from the vertical, normal stress acting is 30.964. So per unit area, that is per mm square, 30.964 Newton is the force acting in this direction. Okay, that is perpendicular to this plane. Now along the plane, shear stress 2.33 megapascal. So if the material is weak in normal stress, it can break due to excessive normal stress, or if it's weak in shearing, it can break due to shearing. So material should be able to resist stresses more than this. Okay, we have checked on a plane which is inclined 30 degree. So some of the planes the stress can be more, so that we need to find out which plane you are having maximum normal stress and which plane you are having maximum shear stress. That we'll learn later. So on a given plane, so you can find out the normal and shear stress like this. Let us work out another example. At a certain point in a strained material, the value of normal stresses 80 megapascal tensile and 60 megapascal compressive are acting in mutually perpendicular directions, along with the shear stress of magnitude 25 megapascal as shown in figure. Find the normal stress and shear stress on a plane inclined 30 degree from the horizontal as shown in figure. So normal stress acting on this element is 80 megapascal tensile, and in y direction you have 60 megapascal compressive, and shear stress is shown like this. On the right face it's shown upward, so it is positive. Shear stress is positive. Sigma x is positive 80 megapascal. Sigma y is negative because it's compressive, so it is negative minus 60 megapascal, and shear stress is positive 25 megapascal. Now the angle theta is shown from the horizontal, so you have to take the inclination, you have to measure the inclination from the vertical. So from the vertical, this angle is 60 degree. This angle, it's 30, it's 90 minus 30, you'll get the inclination of this given plane from the vertical as 60 degree. Or you can take minus 120. So this angle from the vertical, clockwise you should measure minus. So minus 120 you can take, or plus 60. So plus 60 is the inclination of the given plane. Now you can find out the normal stress. Normal stress on the given plane is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Sigma x is 80 and sigma y is minus 60. So 80 minus 60 by 2. And sigma x is 80, sigma y is minus 60. So minus of minus 60 make plus, it will make plus. So 80 plus 60 by 2 cos theta is 60 degree. plus 25 sine 2 into theta 60 degree. So you'll give 80 minus 60 20 by 2 10, 80 plus 60 140 by 2 70 cos 120 plus 25 sine 120, which gives sigma as minus 3.349 megapascal. Compressive, minus indicates compressive stress. So on this plane the stress is compressive, it is acting towards the stress will be acting towards that plane, and the magnitude is 3.349. So some of the planes you will have tensile stress. Say if you take the vertical plane, the stress is 80 megapascal tensile. On a horizontal plane you have compressive stress of 60 megapascal. But on this given plane the stress is compressive, but its magnitude is very small, 3.349 megapascal. Now let us check the shear stress. So shear stress on the given plane, the equation is this: sigma x minus sigma y by 2 sine 2 theta minus tau xy cos 2 theta. So 80 minus 60, 80 plus 60 by 2 sine 2 theta, theta 60 degree, minus 25, shear stress is plus 25, so minus 25 cos 2 into 60, 80 plus 60 140 by 2 70, 70 sine 120 minus 25 cos 120, which gives the shear stress as 73.122 megapascal. So you are getting the shear stress 73.122 megapascal. So on this plane shear stress is more, shearing stress is more tendency for the material to shear along this plane, but normal stress is compressive, which is small, compressive 3.349 is the compressive stress normal to this plane, but you have large amount of shear stress on this plane, 73.122. We don't know this is maximum shear stress, but we only arbitrarily checked the plane. So on this plane the shear stress acting is 73.122, and this is more than the shear stress acting on the element. So 25 megapascal is a shear stress acting, but on this plane the induced shear stress as a result of this loading, the shear stress induced is 73.122. so it will be acting like this, okay, along this plane, and it will be trying to shear the material. So on this plane, which is inclined 30 degree from the horizontal, you have compressive stress of magnitude 3.349 megapascal. So a very small amount of compressive stress is acting, or normal stress, a very small amount of normal stress is acting on this plane, and the nature of stress is compressive, and its magnitude is 3.349 megapascal. The stress induced perpendicular to this plane is compressive. Along the plane you have a shearing stress of magnitude 73.122. So it is trying to shear the plane, and it is more than the given shear stress. On the element subjected to 25 megapascal shear stress, but due to this external loading, this tensile, compressive, all that stresses, induced shear stress on this given plane is 73.122 megapascal. We don't know what is the maximum shear stress. We learn to find out the maximum shear stress in the next class, but on this plane the shear stress is 73.122 megapascal, and it will be acting along the plane. So these are the stresses acting on this given plane. That's all for today. Thank you for watching.